So, hello students, as I told you till that electric current we discussed in the previous video. Now today we'll discuss about the two new terms and then the numericals related to those terms. I will tell you how to solve those numericals, their formulas and all the things. The first things which we are going to discuss today is electric potential. Electric potential. I told you already that previous session that electric potential is one of the term which I have to detail and I have to tell you the things if you want to understand this term electric potential. I told you the number of protons or number of charge which is more on one side and less in one side, so it always flows from more concentration towards the less concentration, like in case of diffusion. So today I'm going to discuss about this electric potential. It is in the same way. Imagine about that one consequence, one condition, that there is a electric field. Now this electric field is containing large number of charge particles present in it. Okay, this is one of the electric field I'm making. Electric field means there is a charge present. The charge may be randomly arranged, charge may be flowing in a sequence, means the form of current. The charge is present. Now one positive charge is there at infinity. Infinity is the distance which is not measured. Okay, so infinity is a distant place from wherever we want to bring. So this infinity is a distance which we had not measured. Infinity is a point from which now we have to bring this unit positive charge. Unit positive charge is what? The charge is having one positive value over it. We tries to bring this unit positive charge up to a point A, say A, in this electric field. The electric field is there which all are having the positive charge, and we are also trying to bring a unit positive charge from infinity to a certain point A in that electric field. So whenever we are trying to bring that electric charge towards this electric field, what we are studying that the same charge always repel each other. So if the positive charge we will try to bring it towards the positive charged electric field, what will happen? It will experience a repulsive force. Repulsion will occur here. So to overcome that repulsion we have to do certain work. So to bring this unit positive charge up to this point A, the amount of work will be done, and that amount of work will be considered as the electric potential of this point. Are you getting it? किसी एक यूनिट पॉजिटिव चार्ज को इन्फिनिटी प्लेस से किसी इलेक्ट्रिक फील्ड में किसी ए पॉइंट तक, या ए लें या कोई भी पॉइंट का नाम हम दे सकते हैं, किसी ए पॉइंट तक लाने में जितना वर्क डन करना पड़ता है वो इस पॉइंट का इलेक्ट्रिक पोटेंशियल कहलाता है. इज इट ओके? आई एम राइटिंग द सेम थिंग. द अमाउंट ऑफ वर्क डन in bringing a unit positive charge from infinity to a certain point in a electric field is called electric potential of that point. Okay, meaning is very simple. This is what it is, only the work done. The work done is always coming in terms of joules. Now it is measured in volt. Measured in volt. Volt is one of the unit which we will use in the next term. I will explain all these things. Now imagine about it, students, just listen carefully, that imagine that there is a point A which we are talking about. Now suppose there is one more point B, there is one more point, suppose C. So number of points are possible here in this same electric field, and if we try to bring the unit positive charge from infinity to any of that point, that will be the electric potential of that particular point. That means they are having different type of work done. So there will be difference in the work done quantity also in between these 2 points or in between these 2 points. So what we will say, if we are trying to bring the unit positive charge from infinity to a certain point, that will be electric potential. Now suppose if we try to bring a unit charge from one point to another point within the electric field, then that will be the difference between the electric potential of these 2 points. एक ही इलेक्ट्रिक फील्ड के अंदर 2 पॉइंट्स के बीच में एक यूनिट चार्ज को अगर हम मूव करते हैं तो उसमें जो भी वर्क डन होता है वो उन 2 पॉइंट्स के बीच के इलेक्ट्रिक पोटेंशियल का डिफरेंस होता है, एंड दैट डिफरेंस वी आर कंसीडरिंग एज पोटेंशियल डिफरेंस. दैट मीन्स डिफरेंस इन इलेक्ट्रिक पोटेंशियल. दैट विल बी अवर नेक्स्ट टर्म व्हिच इज कमिंग, पोटेंशियल डिफरेंस. Potential difference. This we are also considering as voltage. This we are also considering as EMF. It is called electromotive force. Electromotive force. Remember this, electromotive force we are writing, or voltage we are writing, or potential difference we are writing, that is the same thing. What the definition we are going to write about this electric potential or EMF, the same thing, that is the amount of work done, the amount of work done in moving a unit charge from one point to another point within an electric field is called potential difference, or PD, between 2 points. Okay, so it's a measurement we are doing very simply. It's measured by some formula, we are knowing that. So it is measured in volts. It is measured in volts, and the instrument used is called voltmeter. Remember, voltmeter is represented by V, called voltmeter. Voltmeter is always connected in parallel, and it has a high resistance. Remember, its resistance value is high resistance. In case of ammeter, what we studied, it is low resistance was there. It was connected in series. It is connected in parallel. Whenever you have to differentiate between voltmeter and ammeter, the voltmeter is used to differentiate or to measure this voltage or potential difference. Like the ammeter is used to measure electric current flowing. Voltmeter gives the value in volts. Ammeter gives in amperes. Voltmeter always connected in parallel combination. Ammeter always in series combination. Voltmeter is always having high resistance, and ammeter is always having low resistance. The basic difference is found in between these two. Now, if a voltmeter is connected in what? Series. Its combination is what? Its combination always parallel. Now, in place of parallel, suppose we are going to connect it in series, then its circuit will fuse due to heating effect of current. due to heating effect of Carnot. So formula we are just finding out, that is V, that is voltage or volt, equals to W upon Q. V equals to W. This is the basic formula. By use of this formula, we will derive number of formulas afterwards. Okay. So V equals to W by Q. Okay. Now just see, if we talk about volt, so unit we are writing 1 volt equals to 1 joule upon 1 coulomb. Okay. Now see, there are 2 points in electric wire. Okay. Now 1 coulomb of charge we are trying to move from one point A to second point B, and passing this 1 coulomb charge from point A to point B, we have to do 1 joule of work. Then the potential difference between A and B will be 1 volt. Okay. So 1 volt we are defining. If 1 joule of work is done in moving 1 coulomb of charge between 2 points in a conductor, then potential difference between 2 points will be 1 volt. Is it okay? So this is all about what? Electric potential, then potential difference. Correct? Now after this potential difference, there are certain questions are coming. I'm just bringing you to this such questions which are given in your NCERT book. Few questions on this one, Aschan book. If you will see about this, I'll tell you about this Ohm's law and all things afterwards. Let's suppose I'm taking one question from here, on this page number 11. Page number 11. A question is given. I'm just going to solve this. Question they are asking, if the PD, potential difference, question number is 16th B part, PD is given as 10 volts, current I is given as 2 ampere current, and time is given as 1 minute, that means 60 seconds. And how much energy is transferred? They're talking about the energy transferred. Energy we have to find out. Okay. So basically for energy we will use the formula V equals to W upon Q, where W is the energy that we have to find out. V we are knowing already. Q we have to find out. We will modify this formula, that is V equals to W upon I into T. So I and T we are knowing already. It means W equals to what we will say? All three will be multiplied. W equals to V into I into T. That means V is given you as 10 volt into I is given as 2 ampere and time is given as 60 seconds. So 60 to the 120 tens are 1200 joule will be the answer. So in the same way, the different questions which are given in this sections has to be solved, that I will give you. The copies I will send you, so that your work will be to solve those questions, and then if any problems are coming, you have to discuss with me. Okay. Now coming to the next topic, that is electric circuit. Electric circuit. It is a closed and continuous path showing the flow of current is called an electric circuit. Remember, this one resistor I'm making symbols, diagrams I will send you the image. This is one of the ammeter I had connected here. Here I had connected a voltmeter in parallel. Then with the connecting wire I'm connecting it with the battery. Suppose 2 cell batteries here connected. Then a plug key I am connecting here, and then ultimately it is connected in this way. So this circuit we are considering as this is what? It is a open circuit. Open circuit. Open circuit means the current is not flowing. Why? Because switch is off. The second, if I will draw, the second is this. Here also same thing. A meter is here in series. In parallel this voltmeter is placed. Then a cell or battery is placed here. Then this is the plug key. I'm going to complete this circuit, and this switch is on. That means it is a closed circuit. Okay. So what is a closed and continuous path showing the flow of current is called as electric circuit. That's the electric circuit which we are making. So it may be switch off, it may be switch on. A sign you have to show this positive terminal, negative, this is positive terminal, this is negative. Okay, this is positive, this is negative. So positive connected with positive, positive is positive, and negative terminal with negative and negative in this way. So we are determining the things in this same way. Is it okay? So enough for today. Thank you very much.